So, a couple weeks ago, we had been talking about the free response of second order systems, like a spring mass damper system, and breaking down the Laplace transform and then using that to find the characteristic equation of the system, and then using the quadratic formula on that characteristic equation. We can find the roots of the equation, and depending on what those are, if they're repeated, we know the system will be critically damped. If they're too distinct, then it'll be overdamped, and if it's two complex roots, then it'll be underdamped. And then we looked at the equations for the response based on if it was overdamped, critically damped, or underdamped. And a pretty common system that we see is an underdamped system. And based on this complex root, we can see this real part right here is affecting the decay. So this would be, when looking at this graph, this would be like a first order system decaying down to a certain point, and then we can see the imaginary part of our root is what's affecting the oscillation, since it's a sine. And we can see that whenever combining these two functions together is what actually makes up the response of our system.